Hello, my name is Daniel Apotheker, and today we're going to be going over nomenclature, the rules set in place to generate systematic names for chemical compounds.
To understand nomenclature, we need to understand what kind of bonds we're looking at. The first bond is an ionic bond, which is between a metal and a nonmetal. The second type of bond is covalent bonds. Covalent bonds are between a nonmetal and another nonmetal. And then we have acids, which are based on anions, which are the ions attached to hydrogen. So here we have the periodic table of elements. Now in this first set of examples, we're going to be going over ionic bonds, which is again between nonmetals, which are on the right side of this staircase right here, and then metals, which are on the left side of the staircase, except for the elements that are touching the staircase. Now, typically, you're not going to know whether or not you have an ionic bond or a covalent bond. So like I said, in this example, we'll go over just ionic bonds to begin with. So, to start out, we'll look at ionic bonds, again, between a metal and a nonmetal. So how do you name these? So to start out, you're going to name the metal, and then you're going to follow that up with naming the nonmetal. It is important to note that if the nonmetal is a polyatomic ion, you simply just name the ion. However, if the nonmetal is not a polyatomic ion, you're going to name the root and then end in "ide." Some examples of roots are right here on the left-hand side. N, for the element nitrogen, you're going to use the root NITR. For phosphorus, you're going to use PHOS. The rest are listed down here. It is also important to note that if a metal has more than one charge, you're going to express with Roman numerals. Now, let's look at some examples. Let's take a look at our first bond example, NaCl. Na, which has a 1 plus charge, and Cl, which has a 1 minus charge. We know that Na represents sodium, so we write down sodium. And we know that Cl represents chlorine. However, we know that with ionic bonds, we're going to use the root word chlor. So we write chlor. And then because chlorine is the nonmetal, we're going to end it in "ide." So it becomes "ide." So we are left with sodium chloride. Next, we'll look at BAF. Ba is represented by barium, and barium has a 2 plus charge. Then we'll look at F, or fluorine, which has a 1 minus charge. Now we're going to have to first cancel out the charges, so we're going to give fluorine 2 atoms. Now, it is important to note that this is just for the chemical formula, and because we're looking at ionic bonds, the number of atoms is not going to change how the name ends up. So, barium is the first element, and the second element is fluorine. So we're going to use the root word fluor, and we're going to end it in "ide." We end up with barium fluoride. In this last example, we're going to actually look at the chemical name first. So in this example, we're going to use copper with the Roman numeral 2. Now, copper in this case, we know is going to have a 2 plus charge because the Roman numeral represents its charge. Then we have phosphate. And because it ends in 8, we know that this is going to be a polyatomic ion. So, how do we name this? First, we start it with copper, which has a 2 plus charge in this case, and then we're going to write down phosphate, PO4 with a 3 minus charge. Now to cancel out the charges, we're going to have to put 3 atoms for copper and 2 atoms for phosphate. Now that we understand how to name ionic bonds, let's learn how to name covalent bonds. Covalent bonds, we know, are made up between a nonmetal and a nonmetal. So how do we name covalent bonds? I'm glad you asked. To begin, we name the first element and denote its number of atoms. If the first nonmetal contains only 1 atom, we typically do not write mono. We then name the second element and denote its number of atoms. This is followed up by ending the element in the word "ide." Here is a chart of the prefixes used for an element with any amount of atoms from 1 to 10. For one number of atoms, we're going to use the prefix mono. For 2 atoms, di. For 3 atoms, tri. 4 atoms, tetra. 5 atoms, penta. 6 atoms, hexa. 7 atoms, hepta. 8 atoms, octa. 9 atoms, nana. And 10 atoms, deca. Now, before we look at some examples, it is super important to note that you only express the amount of atoms when looking at covalent bonds and not ionic bonds. Let's test our knowledge with some examples, shall we? In this first example, we'll look at N2F5. Now we know that the 2 is going to represent 2 atoms. So we know that that root is going to be di. Then we take the element and we just name it as it is. In this case, nitrogen. We then look at the second element, which has 5. We know that 5 is used with the prefix penta. And then we take the root word for this element, which is F for fluorine, so the root is fluor. And then we end it in ide, dinitrogen pentafluoride. In the second example, we have CO. Now, we know that both of these elements only have one atom. However, in the first element, we're not going to include any prefixes, so we just write it as it is, carbon. In the second element, we are going to write down mono for one atom. Then we take the root word for this, which is oxygen. The root is ox. And then we end it in ide, so it's going to be carbon monoxide. In this last one, we're going to look at a chemical name first, and then we're going to try and figure out the chemical formula. So we have phosphorus, which has no prefix, so we simply just write P. And then we have tri, which is going to have 3 atoms. And then in this root word, we have chlor, so it's going to be Cl for chlorine with 3 atoms because of tri. We're left with PCl3. The last piece of nomenclature we're going to discuss involves acids. Acids get their name based on the anion, which is the ion attached to the hydrogen. For binary acids, which are hydrogen attached with one ion, we use the prefix hydro, followed up with the root, and ending with the suffix -ic. For oxyacids, which are acids containing oxygen, we pay attention to the polyatomic ion. If the polyatomic ion ends with 8, we replace it with -ic. If the polyatomic ion has more than one oxygen, we use the prefix -per and ends with -ic. If the polyatomic ion has one fewer oxygen, we use the suffix -aus, and if the polyatomic ion has 2 fewer oxygen, we use the prefix hypo and ends with the suffix -aus. To put it simply, binary ends in ide, it's going to be hydro, the root word, -ic acid. The rest are all oxyacids. So if it ends in 8, it's going to be the root word with -ic, acid. If it ends in ite, it's going to become the root word ending in -aus, acid. If the oxyacid starts with per and ends with 8, it's going to become per, then the root word, and then -ic, acid. Lastly, if it starts with hypo and then has the root word and ends in ite, it's going to become hypo, the root word, aus, acid. Now let's take a look at some examples. I'm now going to go over how to name acids. So this first one is a simple binary acid. And we can tell because this element right here is just one ion attached to the hydrogen. So because of this, we're going to start out with hydro as a prefix. And then we take the root word for this element, which is fluorine, so the root is fluor. And then we're going to end it in -ic, so it becomes hydrofluoric acid. This next one is an oxyacid, and we can tell because this is a polyatomic ion, bromate. So because of this, we're not going to include any prefix. We're just going to simply take the root word, brome, and we're going to add an -ic, bromic acid. In this final one, we have the hypochlorous acid. So, hypo tells us that the ion has 2 fewer oxygen than its relative ion, and the aus is paired with that. So, we know that the ion is chlorine due to the root chlor, so we can tell that the anion is hypochlorite ion, and it's paired with hydrogen, and we know that because this is an acid. So, to write this out, we just do HClO, which gives us the chemical formula for hypochlorous acid.
So, once someone knows the basics of nomenclature, naming chemical compounds gets a whole lot easier. I hope you enjoyed, and thanks for watching.